Okay everybody, I'm going to go through bonding for people who might be a bit stuck. So the first thing we've got to realise is that the periodic table is really important for bonding. There are three types of bonding: ionic, covalent and metallic. And the most important thing is that you are aware of the line that goes diagonally down the periodic table, starting between boron and aluminium and going all the way down. If you can remember that, that's the first step. On the left of that line, we've got metals, except hydrogen. Hydrogen belongs over there. On the right of the line, we've got non-metals. Now, if two things are on the left of the line, for example, titanium, if you have two titanium atoms, it will be metallic bonding. If you've got two things that are on the same side of the line on the right, so two non-metals is covalent. So 2 times non is covalent. Now that means shared outer shell electrons. Okay, if you have one metal and one non-metal, then we get an ionic bond going to be made. So just to recap that, if you want to work out ionic and covalent, draw the line that separates metals and non-metals, find the element that's in the compound on the periodic table and look at them and where they are on the periodic table. If they're both on the left, the compound is metallic. If they're both on the right, then it's covalent, and if we have one on either side, it's ionic. So to give a few examples, I'm going to show you a couple, and we're going to start with magnesium chloride. Now, magnesium chloride is MgCl2, and you'll see why in just a second. So first of all, we have magnesium, which is in group 2. Okay, that should probably be better written off around like that way. And we have chlorine that's in group 7. Now that's really important, and the group numbers are at the top of the periodic table, which we can see just here and here. So we've got magnesium chloride. The group numbers are important because it is the group number that tells us the outer shell electrons, and that is what determines the bonding. So magnesium is in group 2, which means it has 2 outer shell electrons, and chlorine is in group 7, which means that it has 7 outer shell electrons. Now I'm representing these with dots and crosses. They mean exactly the same thing. A dot and a cross are both electrons, but we're showing them as dots and crosses just so we can see where the electrons are starting and ending up, where they belong and where they go to. So if we look at magnesium like this, magnesium is in group 2. Now it can either gain 6 electrons to fill its shell and give it 8 to make a full outer shell and make it unreactive like the noble gases, or it needs to lose those 2. Now elements will do whatever involves least energy, and that is the less the electrons, the less number of electrons that's moving, the less energy involved. So magnesium is going to lose its 2 electrons. Chlorine, on the other hand, has got 7 electrons in its outer shell. It will gain 1 to fill its shell to give it 8, instead of needing to lose 7, because that would take a lot of energy. So magnesium is able to transfer 1 electron to chlorine, which would fill chlorine's shell up. However, the magnesium still has 1 electron left that it needs to give away. To do that, it must have another chlorine. It can't put that electron anywhere else, and it has to get rid of it in order to empty its shell. So we have another chlorine so that the second electron can be given away. And that's why it's MgCl2, the ionic formula. So that's what we call that, ionic formula. Apologies for the tapping on the screen. Now back to the dot cross diagram for the ionic bonding. We have a special way of writing this out. When it's ionic, we show the elements as they are once the bonding has occurred. So magnesium has lost its outer shell electrons, so we draw it as an empty shell. Now in reality that shell doesn't exist, but we show it in the diagram to show that magnesium has lost electrons. I've drawn square brackets around it. That shows that this is now an ion. It's not an atom anymore because it has lost or gained electrons, in this case lost. Now the magnesium started off with 12 protons in its nucleus. We can see that there because it has atomic number 12. Now the atomic number tells us the number of protons, but it also then tells us that there are 12 electrons as well. So to start off with, over here we had 12 positive protons and 12 negative electrons, and that meant that overall the atom is neutral. because plus 12 minus 12 equals 0. Now the magnesium on the right hand side has still got the 12 protons in the nucleus, we haven't touched those, but it's lost 2 electrons, so it now has 10 electrons, which means that overall there aren't enough electrons now to cancel out the protons. There are 2 positive protons in the nucleus that are not cancelled out in terms of their charge, so we give magnesium a 2+ charge there. The chlorine we show having gained an electron. Okay, this is why these are called dot cross diagrams. Again, square brackets. So we've got the 7 dots that chlorine started with, and we've got a cross now to show that it's gained one from magnesium. Now the chlorine has gained a negative electron, so it is now a chloride ion with a -1 charge. And we have 2 of those. So I'll just draw the second one. And there's the dot cross diagram for magnesium chloride. In an exam, if they ask for the dot cross diagram for magnesium chloride, you wouldn't need to do the working on the left hand side. That is just working. The dot cross diagram is purely the bit on the right hand side. Now if we look at another example, this time I'm going to do hydrogen sulfide H2s as an example. So now we're looking at hydrogen, which is a non-metal, remember, even though it's floating up there. And we're looking at sulfur, which we can see is on the right hand side of the line. So we now have 2 non-metals, and that means that we have a covalent molecule. Now covalent, remember, means shared electrons. That's really important. So again, we're going to look at these elements. Okay, hydrogen doesn't have a group, but it only has 1 electron, so there's only one thing that the electron configuration can be, which is just like that. It's filling the first shell. Sulfur is in group 6, so again, just looking at the outer shell electrons, we have 6 of these. Now hopefully you can see where the ionic formula comes in. Hydrogen has 1 electron, sulfur has 6, sulfur needs 2 more, there's only 1 hydrogen, so we need 2 of these hydrogens in order to make the sulfur work. Now what we can't do is we can't have hydrogen giving its electron to sulfur, because hydrogen is a non-metal, and non-metals always gain electrons, and that's because they're all in group sort of 4 and above really, and they're the ones that need to gain electrons to fill their shell. So what we have is covalent bonding, and covalent bonding ends up looking a bit like a Venn diagram. These elements share their electrons in order to fill their shells. So what we do is I'm going to draw the 3 elements, because we've got 2 hydrogens and 1 sulfur. There are 3 atoms that need to join together, and I'm going to draw them together in a line like that, and that's because chemistry likes symmetry. The S goes in the middle with the 2 H's either side. Okay, now these overlaps that I'm just looking at here, the overlap between the atoms, there's only ever 2 circles involved in an overlap. We don't get overlaps that look like this. It doesn't get complicated, so we don't do that. So back to hydrogen. We're going to look at the outer element first. So outer element first. In this case I'm going to go with the hydrogen on the left hand side. If we look here, hydrogen on the left has 1 electron. That means it needs another electron to fill its shell, because hydrogen is filling the first shell. Remember, it is 2882. Now hydrogen needs to borrow or share across an electron from sulfur, but hydrogen has to pay that electron back. There will always be pairs in the overlap. We have to have pairs of electrons. Sulfur on the right hand, hydrogen on the right hand side, okay, has 1 dot originally, so it needs a cross from the sulfur, and we pair it up with hydrogen's dot, and that always has to be the case. Every dot has a cross in the overlap. So always that. Every dot, sorry about that, has a cross. Now both the hydrogens have 2 electrons, it's filled its shell. We have to look at sulfur. Sulfur had 6 electrons to begin with. If we look up here at this diagram, 6 electrons in its outer shell. It still needs to have 6, but we've already used 2, they're in the overlap. So we count those already, 1, 2, and then we do 3, 4, 5, 6. And if you count the crosses around sulfur, it has 6 crosses just like normal, but now it has the 2 dots from hydrogen to complete its shell. So both hydrogens have 2 electrons. The sulfur has 8, and it is then complete, and that is a covalent bonding dot cross diagram. Right, hopefully that has been a little bit of help, and if anybody needs a hand, then just get in touch with me and show my homework.